We're on the brink of something huge in technology. For so long, AI has just lived in the cloud, in servers. But now it's learning to walk, to interact, to actually operate in our world. We're talking about the new frontier, physical AI and humanoid robotics.
And this quote, it just nails it. It really captures this massive shift we're seeing. For a long time, the whole goal was just about creating an AI that could think. But now, the focus is on embodied intelligence, an AI that can actually do things. We're moving from just pure thinking to real physical action.
So here's our game plan for today. First, we're going to break down what physical AI even is. Then we'll map out the path to actually mastering this stuff, from programming the robot's body to training it in these crazy digital worlds. And finally, we'll see how it all comes together in an ultimate capstone project.
Okay, first things first, we have to get our heads around the core concept, right? Before we can even dream of building or programming these things, we need to be absolutely crystal clear on what physical AI means. Think of it as the brain, the mind, that's going to power these future machines.
So what makes an AI physical? Well, it really boils down to three key actions: perceive, plan, and control. Your average chatbot can't do any of that. Imagine a robot in a factory. It has to actually perceive a box with its cameras, then it has to plan a path to go get it, and finally it has to control its arm to physically grab it. That whole loop, that's physical AI.
So, how do these things actually learn? That's where this incredible concept of embodied intelligence comes in. It's a really powerful idea, but it's simple. Intelligence grows through physical interaction. I mean, think about it. A toddler doesn't learn to walk by reading a book, right? They learn by trying, falling down, and adjusting. This AI does the exact same thing, learning from trial and error, completely grounded in the real world.
Okay, so we get what it is, but what does it actually take to build one of these systems? Well, the path to mastering this isn't some random shot in the dark. It's a very clear step-by-step system where each piece of knowledge builds on the last. Let's take a look at how that progression works.
And you can see this journey is super logical. You have to start with the fundamentals of physical AI itself. Then, from there, you get into the specifics of programming, especially how the robot sees and understands language. And this next part is absolutely crucial. Before you ever touch a piece of hardware, you learn how to use simulations to train safely. Every single step is a necessary building block for the next.
All right, now let's get into the nitty-gritty of it, programming the actual robot body. This is where the code really meets the metal. How in the world do you program a robot to see its environment and then do something? Well, it all boils down to connecting two absolutely key ideas: perception and action.
The entire system, the whole thing, hinges on the connection between these two. Perception is the input, right? The robot sees a steaming cup of coffee. Action is the output. Its programming instantly translates that visual data into a command, like pick up the cup. The real magic is creating that seamless, instantaneous link between seeing and doing.
And to make that magic link actually happen, you need a pretty specific set of skills. We're talking about things like ROS2, which is basically the Windows or Linux for robots. It's the operating system that makes all the parts talk to each other. You also have to tackle these incredibly hard problems like locomotion. And it's not just about moving legs, it's about dynamic balance, constantly adjusting to stop a multi-million-dollar machine from just falling over.
Now this brings up a huge, and I mean huge, practical problem. If you're developing code for a really complex, really expensive humanoid robot, you can't just let your first draft run wild on the machine. The risk of breaking something is just enormous. So how do you practice? How do you train the AI safely?
Exactly. This is the million-dollar question. Quite literally. You've got this incredibly sophisticated, delicate piece of hardware. One single wrong line of code could lead to a very, very costly accident. It's a major bottleneck for anyone trying to develop this stuff.
The answer, and it's a brilliant one, is the digital twin. You create a perfect, physics-accurate, virtual replica of the robot. It's a digital sandbox where you can run millions of tests. You can have the AI try to walk, let it fall over 10,000 times, and learn from every single mistake, all without ever putting the physical hardware at risk. It's how you get that rapid, scalable, and most importantly, safe development.
So after you've mastered the fundamentals, the programming, and the simulation tools, it is time to put it all to the test. This is the final leg of the journey, where all those individual skills you've learned get combined to create something genuinely impressive.
This is it. This is where theory becomes reality.
The final challenge isn't just another homework assignment. It's a comprehensive project that's designed to prove you have mastered the entire system, from top to bottom.
And just look at what goes into this. It's not just one skill. It's everything working together in harmony. You're combining real-world perception systems, the advanced locomotion code for movement, and those vision language action models that connect a spoken commands to a physical task. The goal is nothing less than a complete functioning physical AI system.
You know, this quote really sums it all up. And that term, AI native, is so important here. It means this isn't just traditional engineering with a little bit of AI sprinkled on top. No way. This is a curriculum that's been built from the ground up, with AI at its absolute core, designed specifically for this new era of intelligent physical machines.
So the ultimate takeaway is this. The skill set we need is no longer just about software that lives on a screen. It's about building the intelligent machines that are actually going to inhabit our physical world. This is the toolkit for the next technological revolution. So the final question isn't just whether you're ready to build this future, but are you ready to live in it?